I would like to represent the results of our research on the topic choosing the best location for a trip based on the TOPSIS method. Authors are Oleh virus, Pavlo, Ilchuk, Olha, Kots, and Yurii virus from the Polytechnic National University. Traditional selection methods are often reliant on recommendation of superficial assessments, frequently overlook significant factors that can impact the quality of the travel experience. This oversight increases the risk of traveler dissatisfaction and inefficient resource allocation. This study focuses on the decision-making process involved in selection the optimal travel location through a multi-criterial assessment. This process entails analyzing and evaluating various tourist destinations based on an array of criteria, including cost, safety, climate, and cultural or historical attractions. Tourism, as one of the more dynamic sectors of the global economy, continues to grow rapidly, stimulating social and economic development. An important factor contributing to this growth is the development of information technologies. More than 65% of travel booking worldwide were made online. This indicates that digital platforms have become key tools for finding information, comparing prices, and booking services. More than 80% of tourists pay attention to online reviews before booking a hotel and tour. This shows the growing importance of collective experience and opinion in the decision-making process. Digitalization has led to a change in consumer behavior in the travel industry. Modern tourists expect quick access to information, personalized offers, and convenient booking methods. 53% of travelers want to receive individualized recommendations based on their preferences. This encourages companies to implement modern technologies such as artificial intelligence and machine learning to analyze customer data and create personalized services. The development of mobile applications has also had a significant impact on the travel industry. Mobile technologies allow tourists to plan trips, book tickets and hotels, and get real-time destination information. Because of these trends, the development of tools that help tourists choose the best location for travel in the face of uncertainty and changing circumstances is particularly relevant. Decision support systems can be an important tool to improve the quality of the travel experience and help the industry grow in a challenging environment. Today's market offers a wide range of software solutions and services that help travelers in the process of choosing tourist destinations. These tools greatly facilitate travel planning by providing users the access to a wealth of information about various locations, services, and reviews from other tourists. In order to better understand the current state of the market and identify opportunities for improving the process of choosing tourist destinations, we conduct a comparative analysis of several popular services, namely Booking.com, TripAdvisor, Airbnb, and Kayak. The selected tools are evaluated according to a number of criteria, such as functionality, quality, and volume of information, ease of use, personalization, support for multi-criteria analysis, and others. This allows us to identify the strengths and, importantly for us, weaknesses and understand what gaps exist and how they can be used for potential opportunities. Multi-criteria decision-making offers a structured and objective approach to evaluating alternatives based on multiple criteria settlements. This methodology enhances the decision-making process by fostering informed and transparent outcomes, thereby minimizing subjective and potential errors. Among the widely recognized methods of multi-criteria analysis are the analytic hierarchy process, the eliminating and choice expressing reality method, the preferences ranking organization method for increment evaluations, and the technique for order preference by similarity to ideal solutions, TOPSIS. The TOPSIS method is conjunction with contemporary data analysis technologies can greatly enhance the quality of services within the tourism industry. This highlights the importance and practicality for further research and development of decision support systems aimed at selecting travel locations used the TOPSIS method. There is a pressing need to develop a system that simplifies the process of identifying and choosing the optimal travel destinations, aiding individuals in making informed decisions through objective assessments of various touristic locations. The primary goals include creating a tool that accommodates the needs and preferences of travelers while offering a thorough and efficient evaluations of alternative destinations. The proposed applications enable travelers to easily and effectively select the best locations for their journey, and by allowing them to customize personal preferences and criteria, receive tailored recommendations, and explore detailed options. To successfully implement this system, it's crucial to define its key components and their interactions. All about input data, output data, system features, database, functional and non-functional requirements are highlighted in our research. To identify the optimal approach for developing a decision support system and at selecting trip locations, it's essential to explore various alternatives and access them through morphological analysis. We created various logical and practical combinations of parameters that represents different system options table on the slide. The select of the best alternatives is essential to establish evaluation criteria that reflect the system keys requirement, like user convenience, data accuracy and relevance, personalizing options, development and support costs, monetization opportunities, prospects for development and scalability. We access each option based on defined criteria as an endpoint on the scale that enables us to compare alternatives according to the adherence and established requirements. The best options in the first alternative, which involves developing a web application with a graphical interface that utilizes its own database for obtaining up-to-date location data. A use case diagram helps identify and describe the primary scenarios in which the system will be used, which is vital for defining its functional requirements. To gain a clearly insight into the interaction scenarios, we have created simple use cases for our applications. The activity diagram illustrates the sequences of actions, conditional transactions, and parallel processes, showing how different activities interact to achieve a specific object. In the contents of our decision support system, designed to determine the best trip location, the activity diagram encompasses several key processes, like user authorizations, establishing criteria, saving those criteria, requesting a recommendation, processing the request, and displaying the results, along with detailed view of individual locations. Multi-criteria decisions analyze methods are utilized to choose the best option while considering various conflicting criteria. We have analyzed methods with weighting factors, like Pareto method and lexicographical order method. Methods with weight factors, weighted sum model, weighted product model, multi-objective optimization based on ratio analysis, graph theory, and matrix approach. Methods of distance to references solution, like technique to order of preferences by similarity to ideal solution, TOPSIS. Wise критомережка оптимизация и компромиссное решение. Methods by on pairwise comparison, analytic hierarchy process, eliminations and choice translating reality. Method of fuzzy logic and artificial intelligence, fuzzy analytic hierarchy process, fuzzy TOPSIS. Comparative analysis of various multi-criteria decision-making methods you can see on the slide. They conduct an objective assessment and effective ranking of tourist destinations. We choose the TOPSIS multi-criteria decision-making method. Detailed of it and example of implementation you can find in our research. Now, we can illustrate how we integrated the selected methods and tools to develop a functional application that meets user requirement and effectively operates the TOPSIS algorithm in real-world environment. Superbase was utilized for backend and database management. It's an open-source backend service platform that provides instant APIs and real-time functionalities built on PostgreSQL. Superbase simplifies database management by offering an intuitive interface that seamlessly integrates with front-end applications. It was selected for ability to deliver a scalable and secure database solution without requiring extensive infrastructure management. The database structure is a crucial system component as it dictates how data is stored, organized, and accessed for processing. The database architecture is designed to facilitate efficient storage and rapid access to data related to users, their preferences, evaluation criteria, and information about tourist locations. You can see on the slide. The TOPSIS algorithm was implemented using Python programming language, which offers flexibility and ease of integration with other web application components. The implementation is organized with the TOPSIS class that includes methods corresponding to various stages of the algorithm. To ensure high availability and scalability, the TOPSIS algorithm was deployed separately on a service hosted in the Amazon Web Services cloud infrastructure. This approach has several significant advantages. First, AWS cloud services make it easy to scale computing resources depending on the load, which ensures stable operation of the applications as the number of users increases. Secondly, the use of cloud infrastructure guarantees high service availability and minimal downtime due to distributed architecture and automatic disaster recovery. In addition, AWS offers a wide range of tools to ensure data security, including encryption, access control, and security monitoring. Placing the algorithm on a separate server also makes it easier to integrate it with other components on the web application via APIs, which simplifies system development and maintenance. Finally, the use of cloud services allows you to optimize the cost of maintaining and updating server hardware, as AWS takes care of most operational tasks. The web applications plays a key role in ensuring that the decision support system is accessible and easy to use for a wide range of users. An intuitive and efficient user interface makes it easy to interact with application, customize selection criteria, receive recommendations, and view detailed location information. The web application was developed using the React front-end framework and the TypeScript programming language with Superbase and AWS integration to provide back-end functionality. Superbase is used for user authentication, and database management based on PostgreSQL. It stores user data, the criteria settings, and location information. The TOPSIS algorithm, implemented in Python, was hosted on a server with AWS infrastructure. Such main libraries were used to implement application functionality as Actions is a library for executing HTTP requests used for communicating with Supabase and AWS backend servers. It simplifies data exchange between the front end and server components by providing asynchronous request and response processing. MoMLeT is a set of components for React and simplifies user interface development. MoMLeT offers ready-made stylized components and themes that enable you to quickly create a modern and intuitive UI quickly without having to write your styles from scratch. React Router DOM is a library for routing React applications that facilitates navigation between different pages of an application IO. The application's functionality includes the ability to log in using user credentials provided through integration with Supabase. Users can customize and save their criteria for selecting locations with an interactive slider that features multiple components. This slider allows setting ways for different criteria such as cost, safety, climate, transportation, and cultural attractions. The algorithm processes the data and returns a list of recommendation locations ranked by the degree of compliance with the specified criteria. The results are displayed in convenient format, which each location includes basic information such as name, image, and similarity to users' preferences. Users can view detailed information about each location by clicking on it from the list of recommendations. The detailed information page provides advanced data, including a detailed description, photo, and other relevant information. As a result, the development application provides a full cycle of interaction from setting personal priorities to receiving personalized recommendation and getting to know the selected locations in details. Integration with Supabase and AWS provides a reliable and scalable platform for storing data and processing complex computations. And use the modern libraries contributes the criterion of a convenient and attractive user interface. The screenshot of criteria settings screen shows an interactive slider and a pie chart that allows users to set and visualize the weights of different location selection criteria. A screenshot of the results screen shows a list of recommendation locations organized by the degree of compliance with the established criteria, figure B. Finally, a screenshot of the individual location screen shows detailed information about the selected locations, including a description, photos, and ratings, figure C. Let's conclude. The researcher represents a decision support system for choosing the optimal location for travel based on the TOPSIS method. An important component of the development process was the use of system analysis tools. The developed system allows users to customize the criteria for selecting tourist locations, set weighting factors, and receive personalized recommendations based on multi-criteria analysis. The integration of the TOPSIS algorithm ensures the objectivity and accuracy of assessment alternatives, which is confirmed by a benchmark example of the applications. Users can quickly and conveniently receive relevant recommendations, which increase the efficiency of travel planning. The use of modern technologies, such as React and TypeScript for front-end development and Supabase for database management, contributes the creations of productive and scalable applications. The results of using the system demonstrates its effectiveness in providing users with relevant informed recommendations on choosing a travel destination. The system is only an initial and basic implementation. Prospects for further development of the application include expanding the database of tourist locations and criteria and integration with external services to obtain up-to-date information such as weather, ticket prices, and user reviews. Thank you for your attention.